Hi everybody, welcome to Math with ACE. We are going to be continuing with the sampling distribution of sample means and statistics and doing some examples. Now we're going to work out these examples using formulas as well as using technology. As usual, I'm going to be sticking with Stapplet as it is a free resource online that you can use. You can also use a Texas Instruments calculator and you can use tables if you'd like, but I'm going to be sticking with technology and by hand. An unknown distribution has a mean of 90 and a standard deviation of 15. Samples of size n equals 25 are drawn randomly from the population. I want to pause right there and let you know that when you see that samples of a size, that's telling you we are no longer dealing with the population. We are dealing with the sampling distribution of sample means. So find the probability that the sample mean is between 85 and 92. So we are looking for the probability that 85 is less than or equal to x bar is less than or equal to 92. So what is the probability that a sample mean is between these two? That means I can no longer just use the standard deviation and the mean. I need to make adjustments to the standard deviation in order to have it accurately reflect the situation. So recall that the mean of a sampling distribution of sample means, that's equal to the population mean. However, the standard deviation of the population needs to be divided by the square root of the sample size in order to be accurate for the sampling distribution of sample means. So as soon as I see the word samples, I need to go ahead and use these formulas where I'm adjusting based on the sample size. And here my sample size was 25. So I'm told that the mean is 90. I'm also told that the standard deviation is 15 and that the sample size is 25. So what I can do is I can write down what the mean is, I can write down what the standard deviation is, and then I can use that to help me with my calculations. The mean of the sampling distribution is equal to the mean of the population, which was 90. The standard deviation of the sampling distribution is equal to the standard deviation of the population divided by the square root of the sample size. If we take the standard deviation of the population, which is 15, and divide it by the square root of 25, the square root of 25 is 5, and 15 divided by 5 is 3. So now we're actually working with a mean and a standard deviation that we have, and we can calculate the probabilities. And I will go through and I'll show those in a little bit, but I'm going to work through the next problem and then we'll do the calculator portion. The length of time in hours it takes a group of people over 40 to play one soccer match is normally distributed, that's cool, with a mean of 2 hours and a standard deviation of 0.5 hours, okay? A sample of size 50 is drawn randomly from the population. Ding, 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 that means we need to adjust our values. Find the probability that the sample mean is between 1.8 hours and 2.3 hours. So right off the bat, I want to record the population mean is 2 hours, and the population standard deviation is 0.5 hours, and the sample size is 50. Now I want to know for the sampling distribution, what does that mean and what is that standard deviation? So the mean of the sampling distribution is going to be the mean of the population, which is just 2. But the standard deviation of the sampling distribution is going to be the standard deviation of the population divided by a square root of the sample size, which is 50 in this case. Right notation. So I'm going to take 0.5 and divide that by the square root of 50. And I'm going to use my calculator for that. And when I do that, I get a value of 0.071, so 71 thousandths for my standard deviation. And then I'm going to use technology to help me determine the probability that the sample mean is between 1.8 and 2.3. You could calculate z-scores for this if you wanted to, and then use the standard normal calculator, or you can just use the normal calculator. It depends on if you're using like a table of values. If you're using a table of values, you need to take the z-score for each of these. And remember, a z-score is the value minus the mean divided by the standard deviation. But if we're talking about the sampling distribution, we know we need to adjust this so that the sample mean is subtracting the mean of the sampling distribution and dividing it by the standard deviation over the square root of n, which is the standard deviation of the sampling distribution. Okay, we'll come back to that as well in a calculator. In a recent study, it was reported that the mean age of iPad users is 34 years. Suppose that the standard deviation is 15 years and you take a sample of size n equals 100. Again, ding, 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 sampling distribution. I need to make some changes because they said sample was taken. What are the mean and the standard deviation of the sample mean ages? Well, recall the mean was 34 and the standard deviation was 15. But for the sample mean, so the sampling distribution, that's the same as the population, which is 34. But the standard deviation is equal to the standard deviation of the population divided by the square root of the sample size. So we have 15 divided by the square root of 100. Square root of 100 is 10, and 15 divided by 10 is 1.5. So that is our new mean and standard deviation. What does the distribution look like? Well, what we know based on the central limit theorem is that as the sample size gets larger and larger, the sampling distribution becomes more and more normally distributed. What number is large enough? Safely, we like to say 30. It's about when n equals 30 that the sampling distribution starts to look and feel normal. And so because n is 100, we're going to say this distribution looks approximately normal. Find the probability that the sample mean age is more than 30 years. That's asking me to calculate the probability that the sample mean is more than 30 years. And then I'm also asked to find the 95th percentile. Well, we want a value then, so we're going to switch the way we use the calculator in order to perform this. Let's pop over to Staplet to answer some of these questions. Okay, going back to our first example where we know the mean now and the standard deviation that we're using for the sampling distribution. These are now just normal calculations. So we go to Staplet and we select normal distribution, and we know that the mean is 90 and the standard deviation, which has been adjusted for the sample size, is now 3. I'm going to plot that distribution. I want to know the probability of being between 85 and 92. So 85 is my left boundary and 92 is my right boundary, and then I can calculate that area. It does calculate the z-scores for me, and I have an area of 69.97. So I can go ahead and enter the 69.97. So the probability of being between 85 of the sample mean being between 85 and 92 is 69.97%. Now we're talking about the length of time it takes people over the age of 40 to play the soccer match. We knew that the mean was 2, and we had an adjustment for the standard deviation of a sample size of 50. So we square rooted that, and we got the standard deviation to be 0.071. And in this distribution, I wanted to know about the probability being between 1.8 hours and 2.3 hours. How likely is that? Well, if you look at our distribution, 1.8 is pretty close to almost 3 standard deviations away, and 2.3 is further than 2 standard deviations away. So the z-score for the left boundary is negative 2.8, and the z-score for the right boundary is 4. So you're way above. So that's very, very likely that this game is going to be finished between those two times. The probability was 99.76%. Or 0.9976. So how I would answer this in context is I would say the probability that sample mean is between 1.8 hours and 2.3 hours for the group of 40 to play the soccer match is 99.76%. So super, super likely. Moving on to the iPad users, the average age was 34. So now we have a mean of 34. And then our standard deviation was adjusted to be 1.5. Now, we want to know the probability of being more than 30 years. Well, we're not between two values now. What we want is we want the area to the right of 30 because we're talking about more than. And remember, looking at the number line, did I shade numbers that are more than 30? Yes, I did. And if the average is 34 and we're talking about more than 30, that's a lot of people. So this makes sense that it's 99.62%. So how would I say that? I would say that the probability that the sample mean age is more than 30 years old is 99.62% for iPad users. The last part of this question asked me to find the 95th percentile. So I can't calculate the area. I'm given an area and I need to find the value. So I need to switch this operation to calculate a value. And I want to do 95th percentile. Now remember, percentile means from that value down, which is left. So I'm calculating, that means this value of 36.467, that's the age that is 95% is equal to or less than this value. So here, I know that, get out of my table here that I've created, the 95th percentile for the sample mean is 36.467, so 36 and a half years. 36.467 years. I know it's really, really small since I'm sharing screen, but you can hear me say it. 36.467 years is the 95th percentile for the sample mean age. Okay, and it says to one decimal place, so we're going to make that 36 and a half exactly. Okay. Make that a little bit bigger for y'all. There you go. You can do that for this one as well. And I'll just do that. There we go. Okay. Editing on the fly. Okay, last problem. We haven't done this one yet, so we'll approach this all together. So the mean number of minutes for app engagement by an iPad user is 8.2 minutes. Suppose the standard deviation is 1 minute, and we take a sample of 60. So again, ding, 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 this means we need to make some adjustments. What is the mean and the standard deviation? Well, the mean stays the same. That is 8.2. But the standard deviation of 1 needs to be divided by the square root of 60 to adjust for that sampling distribution. So 1 divided by the square root of 60 gives me 0.129. Okay, so in my calculator, or when I'm using the normal distribution, I want to enter 0.0129 rather than 1. So now I can plot the distribution. What is the standard error of the mean? So what is this standard deviation? It's 0.129. Whenever we adjust and use the sample data, we're calling that the sample error, a standard error. Now I want to find the 90th percentile. Well, I'm actually already in the right screen. So 90th percentile means I just change this from 95 to 90. And that value is 8.365. So we want to interpret this in a complete sentence. So 90% of users have an app engagement by I would say iPad users, let's throw that in here, have an app engagement of 8.365 or less. Some people interpret the percentile to be equal to the value, and some people it's just less than. So I would say, I actually prefer just less than. So I would say 90% of iPad users have an app engagement of less than 8.365 minutes. Okay. Now, what about the last one? The last one is asking us to calculate a probability. What is the probability that the mean is between 8 and 8.5 minutes? So I need to switch to calculate an area, and it needs to be between because I have two values. So if you don't have enough boxes, that means you need to make some changes. So between 8 and 8.5 minutes, I calculate and I get 92.95%. Okay, so the probability of the sample mean being between 8 and 8.5 minutes for iPad user engagement is 92.95%. And talking about the numbers in addition to the fact that it's iPad gives context and relevance to the problem. And we always think that context is really, really important. All right, hopefully this helped you calculate with the sampling distribution of sample means. And we're going to be moving on to calculating confidence intervals in our next series of